Hello students, welcome back to OrganiChemVerse YouTube channel. In this video, I am going to explain chlorination of methane and its mechanism. Many students will not understand what sort of questions they might get based on mechanism, or some might even think that mechanisms are not important, or why should we even learn it. It's always better to understand the mechanism of a chemical reaction and remember it so that you can predict what is the product for the given reaction. So let's get started with the chlorination of methane mechanism. What is mechanism? It is a step-by-step explanation of a chemical reaction. Whenever you write a mechanism, first you have to write the reaction for which you are going to write the mechanism. When methane reacts with chlorine in presence of sunlight, it's going to form methyl chloride and hydrogen chloride. Now, how these products are formed? Is it one step, two step, or multi-step? We don't know. Explaining that is called as mechanism. This mechanism involves three steps: initiation, propagation, and termination. This is very easy to remember as these terms explain what is taking place in the given reaction. The first step, initiation, is where the chlorine will undergo homolytic fission. What is homolytic fission? When a covalent bond is broken and one electron of the bond goes to one chlorine and the other electron goes to the other chlorine. So there is an equal distribution of the electrons from the bonds to the atoms. Therefore, we call it as homolytic fission or homolytic cleavage. Whenever it is homolysis, you always use fish hook arrows. Students, observe here, this arrow is a little bit different, right? It looks like a fish hook. That's why it's called as fish hook arrow. So whenever you represent a fish hook arrow, remember the formed product, whatever the species are formed, these are called as free radicals, free radical species. They will have one odd electron on them. If the first step is involving free radical, remember till the end it will be free radical. So this is a bonus step. Remember students, if the first step is free radical, rest of the reaction will happen through free radical mechanism. That's a reaction intermediate. What is reaction intermediate? It is a highly reactive species which formed during the course of a reaction. There are different types of reaction intermediates. There is a carbocation, carbanion, carbene, and free radical. So if it starts with free radical, there won't be any carbocation or carbanion formation in the reaction. Now let's take the second step. What is the second step? The second step is propagation. How the propagation takes place? Obviously, the methane should collide or it should react with the chlorine free radical and it will form methyl free radical and a HCl molecule. This is a neutral molecule, HCl. H from here will react with the chlorine free radical to form HCl. What is left over now? A methyl. Now this methyl will collide with the chlorine molecule. What is chlorine molecule? Cl2. Again it will undergo homolytic fission. So it's going to form methyl chloride and chlorine free radical. I think now you can guess what happens to this chlorine, right? So this is going to react with the other reactant, that is methane, and again it's going to form methyl chloride and chlorine. So the maximum number of reactions taking place is in the propagation, where the reactant methane is going to react with free radical to form our major product, that is chloromethane. That's why it's called propagation. The reaction is keep on happening. Now at one point the reactant must be fully consumed in the reaction and there has to be a termination. Therefore termination is the last step. In the termination, whatever the free radicals are left over, right, they collide and then they will form product. Say in this case chloromethane. Say there is a possibility that a methyl free radical might collide with the other methyl free radical as well. But this is very rare because the number of species of methyl free radical itself will be very less. Can chlorine and chlorine react? Yeah, that is also possible, but the quantity will be very less. That's why we tend to ignore them. Okay. So what is termination? Where the free radicals combine together to form a stable product. Since these species are less in quantity, their collision frequency will also be very less. So this is mechanism of chlorination of methane, where you are showing formation of a methyl chloride and hydrogen chloride. Now let's read out a question based on this mechanism. During the free radical chlorination of methane, which of the following reactions has the lowest collision frequency? We know that by now a methyl colliding with chlorine free radical is the lowest collision frequency due to their concentration, which is less. Therefore, what is the right option? Look for this reaction. Where is it? It is in option A. Therefore, the right option is A. This is how you have to remember how a mechanism can help you to solve a given question. Thank you for watching this video. Bye.